There we go, that's better. Sorry guys. Okay, we're gonna look at, in this video, we're looking at target 1.5. I can use proportional parts within triangles to solve for the missing pieces of a triangle. So this one really is an extension of what we did yesterday. There's just like some fun new theorems that let us do some cooler new things, okay? So the first thing we're gonna look at is the triangle proportionality theorem. Sorry. That's our first theorem. We need a new stylus. This one's chewed up. So we have our triangle proportionality theorem, and the triangle proportionality theorem states if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. And what it really means is we have these symbols here. These symbols mean parallel. Okay, so it's telling us those are our parallel lines. So a line parallel to this side is intersecting it. Okay, it's cutting it right down the middle. Well, not down the middle, I guess. It could be anywhere, but cutting it through the middle. It's dividing our other two sides proportionally. So we have our side here, which goes from A to B, and it stops at D in the middle. And it goes from A to C, and it stops at E in the middle. And so really what this is telling us with these two sides, right, and this one stops. So yesterday we kind of looked at these and we split these triangles apart, right? So now what this tells us is we do not have to split these triangles apart. We can just say the top over the bottom, so like this A to D over DB. It's nice and red. AB over DB is going to be equal to the same thing here, this top over this bottom. AE over EC. Okay, so AD over DB is going to equal AE over EC. Okay, so if I'm just dealing with those sides, I do not have to split my triangle apart. So let's look at an example. Looking at example 1, we're going to solve for x. Okay, so I like highlighting my sides, and then I go to the point that's not touched by highlighting. Okay, so those are our parallel sides, and I'm going to start at this point, and I'm going to travel down one of my sides. I'll choose the left side first. Okay, so that's the direction I'm going in. So this is 24 over 10. And then I'm going to do the same thing. I'm going to start back at this point, and I'm going to travel down the other side. And go 12 over x. Okay. There are several ways to set these up, right? You could still start with your variable, and most likely if you're making sure you're matching things together, you'll be correct. Okay, this is just a nice, easy way to make sure that we're always getting everything matched up. Okay. So now I'm just going to cross multiply just like we've been doing. So I have 24 times x and 10 times 12. Those are equal. So 24 times x is 24x. 10 times 12 is 120. x is my variable, so I need to get rid of this 24. So I'm going to divide both sides by 24. And we get x equals, well, 120 divided by 24 is 5. Okay. And again, feel free to use a calculator anytime you need. Okay. Let's look at example 2. Again, solve for x. Okay. So again, I have my two sides that I can see are not quite drawn parallel because of my poor drawing skills, but we're going to say they're parallel. And I can go down either side. I'll go down this side first. So we have 3 over 9. And then I have to go down this side. Well, on this side I have x over something. Okay. This 20 is not in the right spot. This 20 is the whole thing. It's not what's going to fill in that circle there. So we have to think about what we can put in that circle. Well, if this is x and this is I don't know, and they add up to 20, that means I can make a family out of those, and the opposite is going to be what is here. Right? And it's going to be 20 minus x. I'm not going this whole distance. I'm cutting off the part that is x, okay, or taking that away. So this is actually going to be x over 20 minus x. We need new styluses everywhere. That one's broken too. This one's good. X over 20 minus x. I guess I gotta not push so hard. And these are going to be equal. And then our favorite thing to do, right? So we have 3 times 20 minus x and 9 times x. And those are equal. So I'm going to distribute, so I have 3 times 20 and 3 times x, so that's 60 minus 3x. And 9 times x is 9x. Again, we're solving for x, and that x is in more than one place. I'm going to get rid of this minus 3x by adding 3x. And I'm left with 60 equals, well, 9x plus 3x is 12x. I still have this x I'm trying to get by itself, so I'm going to divide by 12. Right? That cancels this out. 60 divided by 12 is 5. 5 is what x is. Okay. All right, let's look at our next example. So in example 3, we're solving for x and y. We'll start by solving for x. X is on these sides, and there's just numbers on the other side, so I should be able to use my newfound thing. What are we calling it? Triangle proportionality theorem. Sorry, couldn't remember the name. Right, so I'm going to start, here's my parallel sides. So I start at the point that is not part of that, right, and go down that side. So I have x plus 22 over x plus 2. Okay, down the other side, right, start back here. We have 18 over, that's not an x, that's a 6. We can cross multiply, so we have x plus 22 times 6 and x plus 2 times 18. And those are equal. So on this one we have to distribute on both sides, so I have 6 times x, which is 6x. 6 times 22 is 132. Yeah. 18 times x is 18x. 18 times 2 is 36. So I have an x in both places. Again, it doesn't matter which one I get rid of. I'm going to get rid of the 6x, and if you would like to know my reasoning, I like to keep my numbers positive. So I'm getting rid of the smaller x, because then 18x minus 6x is still a positive number, because I don't like negatives. But it really, again, it doesn't matter. If you subtracted 18 and then did it, you would still get the same answer. And that's 12x. 46. Okay. I'm going to move this down. So now I still have this x that I'm solving for. So I'm going to subtract 36. And that's all right, those cancel, and 132 minus 36 is 96. So we have 96 equals 12x. And 96 divided by 12, right? So then I'm going to, because here's my x. So I'm going to get rid of the 12. Those cancel. So we have 96 divided by 12 is 8. Equals x. Okay, we solved for x. Back up to the problem. We still have to solve for y. So this part's done. We still have to do that part. So we're not done yet. Fine. Well, unfortunately, our triangle proportionate theorem only tells us something about these red and these blue sides. It tells us nothing about the parallel sides. So if you're given the parallel sides, if that's where your variable is, you still need to split into two triangles. Okay. So my baby triangle. We have 18, y, and this side is x plus 22. And then we have our big triangle. Move this over a little bit so we have some more space over there. And here we're going to have 18 plus 6, and 18 plus 6 is 24. Okay, I'm going to look get that from doing. This side here is easy, that's just your 20. It's just one solid line, there's nothing being added. So that's 20. And then this bottom side, I have x plus 22 and x plus 2. So I have to add those together. And if I add x plus 22 plus x plus 2, I get, well, x plus x is 2x, 22 plus 2 is 24. Now I'm solving for y. So I'm going to have y over 20. Now again, I get to choose any other side I want. So I could choose 18 over 24 or something with these crazy x's. The simpler one to me seems to be 18 over 24. Again, you want to make it as easy as possible. Don't choose more complicated things. So we have 18 over 24. Set them equal, and then we're going to cross multiply. So I have y times 24. Times 18. That gives me y times, oh, those are equal. Y times 24 is 24y. 20 times 18 is 900. Here's where my y is. Right, again, I want to get it by itself, so I'm going to divide by 24. And I get y equals 15. So this problem was way easier with the algebra, but like the setup was much harder. Where this one was easier with the setup, but then the algebra was much harder. So it's kind of a trade-off with some of these. Okay, so that's our triangle proportionality theorem. The other thing we have is our triangle bisector theorem. Okay. And the triangle bisector theorem states the angle bisector of a triangle will divide the opposite sides in the opposite side into two segments that are proportional to the two other sides of the triangle. So this is kind of a neat little thing where if these two angles are the same, right, meaning that line split that angle right in half, then we can make proportions like with these sides. So again, I always start where the angle is. So I'm going to start up here, and I travel this way and stop at that point. And again, it's A to B, and then B to D. And then same thing, I'm going to start up at that point, travel this way, and that's A to C over C to D. Okay, so again, using that angle bisector theorem, it's just another fun way we have to like set up these proportions before we solve. So let's look at two examples. We have example 4 here. Okay, so I see where our little split is. So all I'm going to do, right, is, again, I start at that point where those angles are, and I'm going to travel until here. Right, so it's kind of like splitting this in half. So I get x and 4. So on my other side, I just start at the same point and end at the same point. And I get 13 and then 6. and I can set these equal. Then just cross multiply. So I have 6. Let's actually, sorry, do the multiplication. So that's x times 6. And 4 times 13. So x times 6 is 6x equals, and 4 times 13 is 52. Here's my x that I'm solving for. So I'm going to divide both sides by 6, because those cancel, and x equals, and you either get 26/3 or approximately 8.7. Okay, so again, I will take either of those. I am missing my page with the answer, so you can be impressed. I did do that in my head. Yeah, approximately 8.7. Okay. One more example. So again, here are my congruent angles. So this line's splitting it. So I can start here. And I have a 14, then an x. And then I have my other side. I have an 11, and then this I am missing. Again, that 25 is not really that piece I need. I can use it to find the piece I need. If this whole thing is 25, and I take away this x to get this piece, this part right here is 25 minus x. Okay? So I have 11 over 25 minus x. And those are equal. So cross multiply. I have 14 times, in parentheses, 25 minus x. And then x times 11. It's not purple. Okay. It's fine. I'm going to distribute, well, 14 times 25 is 350. 14 times minus x is minus 14x. Then I'm going to add, hold on, solving for x, right? And there's 2 of them, so I need to get rid of one whole term of x's. So I'm going to get rid of this 14x. That makes that one go away. And I have 350. And 11x plus 14x is 25x. Okay. Now I just have my x in one spot. So to solve for it, I'm going to divide by 25. And I get x equals 14. That's probably... that is it for 1.5. Remember, our quiz is coming up. It's going to be over target 1.1 through target 1.5. So this is our last target before our quiz. Have a good day.